Hello, we are working chapter 1.37 in the back of chapter 1. And as you can see here, 1.37 asks you to identify any polar covalent bonds and indicate the direction of the dipole moment in the molecules using the symbols partial positive and partial negative there. The lowercase Greek d, delta, means the partial sign. So let's head over to our notebook so we can work this problem. Okay. So 1.37 says A, we have HBr, B, HCl, C, H2O, and D, C4HO, which has this formula. And we'll just move this down here. Great. Okay, so these are the four that we're going to be looking at. And you might find it helpful to have a look at section 1.5 as you're doing this problem, because it lets you know the electronegativities of the atoms that we're looking at. So H has an electronegativity of 2.1, and Br has an electronegativity of 2.8. That means that the bond between the bromine and the hydrogen it's a polar covalent bond. So we would indicate that perhaps by circling it or highlighting or something like that. So since it's a polar covalent bond, we need to identify what the direction of the dipole is. And remember, it needs to go from most positive or least electronegative towards the most electronegative element. And in that case, that is from the hydrogen towards the bromine. And we indicate that using an arrow like this. And we still need to identify where the partial positive and partial negative are. Well, good news for us is the arrow helps us do that, because the partial positive must be on the positive side of the arrow and the partial negative on the negative side. Similarly, chlorine has an electronegativity of 3, which means this bond is between H and Cl is also polar covalent. It means the dipole must go towards the chlorine, and the partial positive lie on the hydrogen and the partial negative on the chlorine. Oxygen has an electronegativity of 3.5, which means it will also have a polar covalent bond with hydrogen. And that means that here we can draw two dipoles with partial positives on the hydrogen and a partial negative on the oxygen. Okay, they're in C3, in CH4O, which I've drawn here. Oh, I left out a couple electron lone pairs. There we are. In this molecule, you can see that we have two polar covalent bonds. We have one there and one there, because oxygen's electronegativity is 3.5, in carbon's is 2.5. So the difference of 1 means that it's also a polar covalent bond, just like between oxygen and hydrogen. So now we have two different dipoles we're looking at, from the hydrogen towards the oxygen and from the carbon towards the oxygen, which means that we have a partial positive now on the hydrogen and on the carbon, and a partial negative on the oxygen. Okay, thank you for being here with me. This has been practice problem 1.37.